Hello, good morning everyone. Today I am going to take a lecture of Operation Research, chapter number 2, Transportation and the Assignment. And our topic is the modified distribution method. We have already seen in our previous lecture what is the feasible solution and the optimum solution. So according to feasible solution, we have three types of the method: the northwest corner method, the least cost method, and the Vogel's approximation method. After finding the optimum solution, we have only one method, the modified distribution method, or you can say that the MODI method. Okay, so let's start. Next is the if. A question given in the feasible solution form, that means we find out the optimum solution, that means the modified distribution method. So first you find out the feasible solution with the help of northwest corner method, least cost method, or the Vogel's approximation method. Okay, so first we have one example, and according to this example we have already allocations are given. Because of we find out only the optimum solution, so feasible solutions already we have with the help of the Vogel's approximation method. Okay, so see here optimum solution for finding this is the Vogel's approximation method, and the total allocation is 19, 5, 10, 2, 14, 7, 16, 2, 8, 8 and 20, 10. So before finding the feasible for solution, first you check here the given problem is the balanced transportation problem. That means the supply and demands are equal. Then we use the transportation problem, that is the balanced transportation problem. So first we find out the total cost price, that means the feasible solution with the help of VM method is 779 rupees. And what is the process? Process is that 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. Okay, so we have 779 rupees the total cost price. Then apply the modified distribution method. So you consider here according to row U1, U2 and U3, and according to column we have V1, V2, V3 and V4. Okay. After that, we find out the occupied cell. So before finding the occupied cell, first you consider here any row or any one column is equal to 0. And what is the logic? Logic is that the maximum allocations according to row or the column you consider here the 0. In case you randomly put here U1 0 or U2 0 or U3 0, it's okay. All methods are correct. Okay, so we consider here this is the three allocations, so V4 is equal to 0. After that we find out the occupied cell. So occupied cell, that means what? This 19, 5, 10 to 47, 62, 8, 8 and 20, 10. Okay, so here this is the row, that means we consider here in the U form, and this is the column, so we consider here the V form. Okay, so here first we write the place value of the occupied cell. So what is the place value? This is the first row and first column. So U1 V1. Okay, this is the first row, fourth column U1 V4. This is the second row, third column. So U2 V3. This is the second row, fourth column U2 V4. This is the third row, second column U3 V2 and U3 V4, and is equal to what? We consider here the values, place values. Okay, so here 19, 10, 40, 60, 8 and 20. Okay, so next one is we write here consider V4 is equal to 0. So U1 plus V1 equal to 19, U1 plus V4 10, U2 plus V3 40, U2 plus V4 60, U3 plus V2 8 and U3 plus V4 is equal to 20. Okay, so we consider here V4 equal to 0. So first you consider here the equation with the form of V4. So here the second equation V4 0. So we get U1 equal to 10. fourth V40 U2 equal to 60, and last V40 U3 equal to 20. So with the help of this U1, U2, U3, we find out the value of V1, V2 and the V3. Okay, put here one by one U1, U2, U3, and we get V1 equal to 9. V2 is equal to minus 12 and V3 is equal to minus 20. Okay, so with the help of this process, we write here U1 10, U2 60, U3 20, V1 9, V2 minus 12, V3 minus 20 and V4 0. After that, we find out for the unoccupied cell. So what do you mean by the unoccupied cell? Unoccupied cell, that means this. First row, second column, first row, third column, second row, first column, second row, second column, third row, first column, and the third row, third column. Okay, so all these cells are the unoccupied cells. So what is the place value? Place value is first row, second column, and first row, third column. So we write here D12, D13. Second row, first column, second column. So D21, D22. Third row, so D31 and D33. All this is the unoccupied cell. So we write here D12, D13, D21, D22, D31 and D33. Okay. So open this term. So D12, first you write here C12 and take here the minus sign. Open the bracket and 1, 2, that means first one is your row and second one is your column. So we write here U1 plus V2. C13, that means first row, so U1 plus V3. C21 minus U2 plus V1. C22 minus U2 plus V2. C31 minus U3 plus V1 and C33 minus U3 plus V3. So with the help of all these process, we put here the values of the unoccupied cells. So C12, the value is 30. So see here C12. This is first row and second column. So 30, first row, third column. So 50. So according to this, you take here the 30 minus. Already given U1 the value is 10 and V2 value is minus 12. So solve this, we get the 32. Next one is the value of C13 is 50 minus U1 10 and V3 minus 20 is equal to 60. D21 70 minus 60 plus 9 is equal to 1. D22 30 minus 60 minus 12 is equal to minus 18. D31 40 minus 20 plus 9 is equal to 11. And D33 70 minus 20 minus 20 is equal to 70. Okay. After finding the unoccupied cell, you check here if all the values of Dij's greater than equal to 0. So this is your optimum solution. Okay, and what is your final answer? Our final answer is with the help of the Vogel's approximation method, the total cost price is 779 is also a optimum solution. Okay, but all Dij's is not greater than equal to 0 because of one value with negative sign. So Dij is not greater than equal to 0. Then we make a loop. So what is the process? Process is that first you draw the table and you write here all the values of the Dij's. That means D12 values plus 32, D13 value is plus 60. See here D12 32, D13 60. So you write here all the values for unoccupied cell and put here plus 1 minus 18 plus 11 plus 17. Okay, after that we make a loop. So what is the process for making the loop? So your loop start with the negative sign. So here the negative value is minus 18. Okay, so loop start with this cell minus 18, and second condition is what? Second condition is that the shape of the loop is a square or the rectangle. Okay, so and all the remaining three corners, the square and the rectangle have the four corner. Okay, so first corner is starting from the negative sign for the unoccupied cell. So remaining three corners must be a occupied cell. Okay, so here Loop start with minus 18. So we move to this cell 8. So this is your first corner. This is your second corner 10. This is your third corner 2. And this is your fourth corner. And all the middle allocation cells you ignore it. That means we use only the three corners 8, 10 and the 2. After that, you consider here randomly, that means starting from, if your loop start with the negative sign, so you consider here the plus sign and alternate. You tack here the negative and the positive sign. So no doubt your loop shape is the square or the rectangle. So we have the four corners, that means 2 plus and the 2 minus. Okay. So here this is your plus sign, and after that we take here the negative sign, positive sign and the negative sign. Okay, next step is what? Next step is according to your negative sign. So see here the negative sign is allocation 8 and here allocation 2. So consider the negative sign and the minimum allocation. So what is the minimum allocation? 8 or 2? The minimum allocation is 2. Okay, so you consider the number 2. If you write here the negative sign, so subtract 2, and if you write here the positive sign, so subtract plus 2. Okay, that means what is the process? Process is that loop is starting from the negative sign. After that, all the three corners we have the allocation cells, and alternate you write here the positive negative sign. Okay, after that, you consider here with the negative allocation, the minimum value is 2. So, we use the number 2 in case if you tag here the negative sign. Okay, if you tag here the negative sign, so you subtract here minus 2. That means 2 subtract here, and here is the positive sign. So, you add 2. Okay, so what is the process? In loop, minimum allocation is 2 with negative sign. So in positive sign, 8 plus 2, and in negative sign, add minus 2. Loop start with negative sign and then put alternate negative and positive sign all corner in the loop. Okay, so here minimum number is 2. So here we write the negative sign. So 2 minus 2 equal to 0. That means this allocation we ignore here because of this is a 0 value. Again here is the positive sign. So here we consider the 0 allocation. So 0 plus 2. Why? Because of here we write the positive sign. Next one is here, next is the negative sign. So negative sign, that means what? 8 minus 2, 6. And here in the 10 positive sign, so 10 plus 2 is equal to 12. Okay, so your next slide is what? Next table is given. The allocation is 19, 5, 10, 2, 8, 30, 2, 60, 0 allocation, 8, 6 allocation because of here 8 minus 2 because here we write the negative sign, and here 20, 10 plus 2, 12 allocation. So see here 19, 5, 10, 2, 32, 47, 8, 6 and 22. 12. That means what? Here in the previous table, we write here 60 into 2. That means 120 we had here the final answer. But here this 2 we move to this cell. So 30 into 2, that means 60. That means the 60 rupees is less from your final answer. That means 779 rupees. Okay. So again, this is your optimum solution or not. So first you again write the U1, U2, U3 according to row, and V1, V2, V3, V4 according to column. So what we do here? You consider any row or column is equal to 0. So we consider here V4 is equal to 0. Again, we write here for occupied cells. So occupied cell is U1 plus V1. See here occupied cell U1 plus V1, U1 plus V4, U2 plus V2, U2 plus V3, U3 plus V2 and U3 plus V4. Okay. So with the help of this occupied cell, we find out the value of U1, U2, U3 and V1, V2, V3 and put all these 6 values according to your table. U1 10, U2 42, U3 20, V1 9, V2 minus 12, V3 minus 2 and V4 is equal to 0. Okay, after that you find out the unoccupied cell. So what is the process? The process is the unoccupied cell is D12, D13, D21, D24, D31 and D33. See here, unoccupied cell is D12, D13, D21, D24, D31, D33. And after that, you put here all the values. First, you write here in the form of C12, C13, C21, C24, C31, C33. Okay, and put here all these values and we get the values of the DIJs. So, see here, all the DIJs greater than equal to 0. Okay, see here, all the DIJs greater than equal to 0. So this is your final answer. So what is your final answer? In unoccupied cells, all values of DIJs are positive. Then iteration is completed and this gives optimum and the unique solution. Therefore, the solution is cost price is 5 into 19 plus 2 into 10 plus 2 into 30 plus 7 into 40 plus 6 into 8 plus 12 into 20, that means 743 rupees. So see here, for feasible solution with the help of the Google's approximation method, your cost price is 779 rupees. And for finding the optimum solution, your total cost price is 743 rupees. Okay, so this is your optimum values. Okay, so here we have again three conditions. If Dij is greater than equal to 0, then solution is optimum and unique, just like your previous example. Second one is if Dij greater than equal to 0, but one value is 0, then the solution is optimum but not unique. And third one is if all Dijs, one value is negative and the remaining values are positive, therefore the solution is not optimum solution. That means this is the degenerate solution. Okay, that means again we find out the occupied cell. After that we find out the unoccupied cell. We make a loop and change the allocation cell. Okay, so this is an example of the modified distribution method for finding the optimum solution.